Hi everyone, my name is Mariana. I work in the Google Cloud Platform team. I'm based in Amsterdam. And today I'm very thankful that you made it for our live webinar on Kubernetes. What we're going to present to you today is in regarding to the hot topic of containers and Kubernetes. And we have a specialized partner based in Berlin, Germany called Endocode. They're Kubernetes specialists, and they're going to give you an overview of Kubernetes, as well as answer any questions that you posted in advance and the top questions that everyone asks about Kubernetes or is afraid to ask. I also want to thank David Aaronchick, our product manager for Kubernetes. He didn't manage to join us live because he's based in the US. And although he likes us a lot, he doesn't like us so much so that he joins us in the middle of the night. So he recorded a short video answering your questions that you posted in advance. Let's start.
Thank you very much for the opportunity to talk about Kubernetes. I'm David Aaronchick, the Senior Product Manager for Kubernetes and GKE, working at Google Cloud. The history of Kubernetes is pretty straightforward. We decided that we had a ton of experience running containers at Google. In fact, Google has been developing and using containers to manage our applications for over 10 years. We decided in the early 2000s that containers was the right way to scale our infrastructure and respond to the massive user demand that we were seeing for our applications. To be specific, everything at Google runs inside a container. Every Gmail, every web search, every MapReduce job, every large data entry, every storage, every database, even VMs that run on Google Cloud run inside containers. As a result, we spin up more than 2 billion containers every week. Now, when you think about containers, getting applications running inside a single container is kind of the easy part. The hard part comes when you want to scale them up, to watch them and make sure they're healthy, to deploy them in a 12-factor way where the secrets and configuration are separated from the binaries that you might be running, to aggregate logs, to do service discovery between them. These are all the complicated things that are involved when it comes to bringing containers to production. At Google, we spent our time building a product called Borg, which is how we run our containers internally. However, in the early 2010s, when containers first started becoming popular broadly and publicly, we wanted to open source Borg, but realized that it was highly bespoke and closely tied to the infrastructure that was running at Google. As a result, we decided to take the same concepts that we had learned over the past 10 years and open source it as part of Kubernetes. And what Kubernetes is designed to solve is all of the things you see here. How do you deploy? How do you manage and monitor these elements? How do you help isolate those containers between the various different workloads running in a single orchestration? Once they're out there, how do you update them and provide service discovery between them? And how do you respond to user demand? You need an orchestrator that understands this and has the same experience as those 10 years of Google running this at scale. As I mentioned, Kubernetes is our solution for that problem. Kubernetes means helmsman in Greek, and it literally is designed to run your containers at scale in production. It's 100% open source and written in Go with over 650 contributors and over 5,000 lines of, pull requests per release. And most importantly is this last line. The question is, it lets you manage applications rather than specific machines. We were lucky enough to just release Kubernetes 1.2, which had a number of very significant elements. You can see some of them here, including a brand new UI. We increased scale by over 400%, now supporting up to 30,000 pods on a single cluster. You can also go by our blog where we show running Kubernetes at scale and handling over 14 million queries per second against a single Kubernetes cluster. We have brand new tools built into the application platform to enable simplified application deployment so that it makes it very simple to deploy and manage configuration of your live and running applications. We've improved automated cluster management, including letting you deploy one application per node in your cluster for things like log shipping and security analysis. We've added brand new third-party extensibility, letting you write your own extensions to the platform without even recompiling. And we've also added node pools, which lets you configure and group certain nodes together, such as high memory, those that require SSD or fast disk, those that require special networking capabilities. You can group those and have the scheduler indicate and deploy only certain applications to each of those node pools. Coming soon in Kubernetes 1.3, in just about 6 weeks at the end of June, we will have another set of brand new features to again make it easier to run your applications on Kubernetes. We'll be improving stateful workload, improving and simplifying running applications such as databases, again, things that require state and things that might be less container ready than those that you might be using today. We'll have the first step towards cluster federation, or as you might have heard of, referred to as Kubernetes, which will let you deploy services that span multiple clusters. We'll be doing more work to increase scale, we expect at least another 200% increase in number of nodes. We'll be adding a number of in-cluster identity and authentication management, including support on both GCP, Google Cloud Platform, and AWS, and open hooks to allow other people to plug in services such as LDAP and Active Directory. We'll be supporting cluster auto-scaling, meaning that if your cluster is now out of compute, it can publish a signal that can be picked up by your cluster manager or your system and ask for more compute. And finally, we'll also be adding scheduled job, which will let you schedule a workload to run on a regular basis. Looking slightly further out beyond that, again, we'll be adding scale, improving security. We'll be adding better support for legacy applications. And we'll also be doing a lot of work to integrate with external services and make it truly simple to run your application on top of Kubernetes. I know there were a number of questions from the community, and I'd love to try and tackle some of those now. The first is Kubernetes just a Google Cloud technology, or does it run on AWS, Amazon Web Services? In fact, Kubernetes runs great on Amazon Web Services and can be set up with a single line command. You can set it up and embrace all the things that you use today, including S3 storage, EBS. You can use your existing VPCs, or any sort of networking that you might have set up and load balancing. There is nothing specific about Kubernetes to the Google Cloud Platform. In fact, we see the majority of deployments out there, both on AWS or on premises, though Google Cloud and the Google Container Engine that Google hosts is growing extremely quickly. A second question we get frequently is, can I run a database on Kubernetes? In fact, even though there will be improved support in Kubernetes 1.3, there's absolutely nothing stopping you from running a database on Kubernetes today. You will mount a persistent disk into your container, much like you would with a VM You wouldn't want to run your MySQL database or your Postgres database using the local VM disk. You would always want to mount it on a network store in case that particular VM went away. You would do the exact same thing. And there are over 15 different network storage drivers that you can use to manage your storage for your persistent data. Finally, we get a number of questions about folks who have already embraced DevOps and might be deploying using Chef, Ansible, Puppet, or Salt. And they want to know whether or not they can use Kubernetes today. In fact, you absolutely can. What you would normally do is deploy a Kubernetes cluster, which you can certainly do using any one of those tools. The setup is normally a one-time activity with upgrades happening at the node level or the master level. And then once it's set up, what you'll want to do is inside your Docker file, you will want to use the exact same recipes and techniques that you use in your basic shell scripting. You will build a container according to the requirements of your application and your enterprise. And then once that is built into a container, you can deploy that either manually against Kubernetes or using one of the many plugins from those different platforms that can deploy to an existing Kubernetes cluster. So if you're already down the DevOps route and are getting efficient, you should continue to do so, and you will see great benefit to building and deploying in a container and really enabling your developers to take control of their application, both on their desktop and running in production.
Thank you, David, for recording the video and for answering the client questions. Working for the cloud platform across EMEA, we have several trusted partners that are specialized in a certain product or several products from our cloud platform stack. And one of our trusted partners is Endocode. Endocode is specialized in Kubernetes and helping you as a client to deploy the Kubernetes technology. And I want to thank Thomas from Endocode that now he's going to give us an overview of Kubernetes and answer some of your questions. Thomas, the floor is yours.
Yeah, thank you very much for attending our webinar. So I've prepared a presentation and we'll go to our presentation now. And
yeah,
where is the presentation? Oh, there it is. Okay. Just a second. Oh, this is the other one. Yeah.
Thank you. Thank you, Mariana and David, for the introduction. So let's deep dive into Kubernetes. I'm Thomas, CTO of Endocode. We are doing professional services with virtualization and containers in Kubernetes. So we want to share our experiences with you and go deeper into the topic. And let's start. We have a lot of questions. One question which always arises if we talk about Kubernetes and containers is, what is the difference between virtualization and containers? So we have to explain what is a container. From a user perspective, a container is a simple entity. From an operating system perspective, it's a Linux process which has resources, access rights, and is based on images. There is the app container image definition. It's a format for compatible runtimes. There is Docker, of course, but there are also other container runtimes which are able to run containers. So normally only no Docker, but there is stuff around which is really exciting. And these are container runtimes. These are tools to start processes in a container. The runtime downloads a container image from Docker Hub, from KIO, from the Google Container Registry, or from your own registry. And then it starts a process inside the container with a limited access right and a limited number of volumes mounted in, and so on. So it's a definition of how to isolate your processes or certain user processes from the rest of the operating system. If you compare container and virtualization, then we have a long list of capabilities to compare. First thing which comes into mind is the isolation. The isolation level for containers is completely different from the isolation level of virtualization. A container is separated by the operating system in namespaces, and it has special restrictions on resources. And a virtual machine runs in a completely different CPU level. So there are 4 rings, normally only ring 0 and ring 3 are used. So this isolation is guaranteed by the CPU, whereas the isolation of a container is guaranteed by the operating system. You can't use a front CPU. So with ARM, you can only run ARM processors. With Intel 64, you only can run Intel 64 processors. And there is no way of doing an emulation of a front CPU this way. And you have to live with the kernel of the operating system. So the Linux kernel is quite major, but you can't emulate a different kernel. This is not completely true because you can run a hypervisor inside a container, but this is out of topic and is a specific topic on its own. The good thing is you don't need to emulate devices, so you can use the devices of the host operating system and just import them. And this is different from virtualization, where you can or where you have to emulate devices, and yeah, this is an impact or has an impact on security. Both has advantages and disadvantages. You have the device drivers of the host operating system, and you have full control which devices can be imported into the container. The access is direct. This means you have the full speed and don't need a VirtIO driver in a container. And yeah, this is completely separate. With the latest version from systemd, you can even do a more and more sophisticated delegation of devices into processes. So expect more to come in the near future, that you only can import certain network devices or something like this in a container. This has a big impact on security and makes your container, I would say, at least as safe as a hypervisor. The CPU performance is 100%. I/O performance is 100% because all devices are imported directly. The root isolation now in a container is working, so you don't need the user directive, but you have it, and you don't need to run your root process, your user processes in a container as root. and there is no way, even if the process escapes from the container and has been a root process, that it can access resources of the host as root. But beyond, there is one thing which is easier: CPU cache attacks. Leaking secrets from one process to another has been shown even in virtualization, and it will be easier, definitely easier, with containers, because there is no hypervisor isolation. But this has not been demonstrated until now, and I'm waiting for a proof of concept. And yes, so this limits your very, very secure applications to the case where you have dedicated nodes for your privacy. But this is not different from virtualization. So yeah, it stays the same. And multi-tenant solution with crypto in your processes should be run on isolated, dedicated hosts. This is nothing new. There is one more thing. The latest version of Rocket, the CoreOS container runtime, is able even to combine both container and virtualization security aspects. It can spawn a small hypervisor, which is part of the clear Linux initiative of Intel, and you get a small hypervisor, and your container is isolated also by a CPU level through these small KVM hypervisors. This is new and is an additional layer of security in the latest versions of CoreOS and Rocket. Yeah, if you want to start with Kubernetes, what do you have to respect? What do you have to do? So let's look into the details. Kubernetes is part of the Diffie initiative, so this is Google infrastructure for everybody else. So this means you can run it on Google and it will work in the Google Cloud, and it will work very well there. But as it is for everybody else, you can use it, put it into any other cloud, use it on your on-premises servers, and whatever you want is only limited by your resources and your time and your fantasy, I would say, yes. What are the prerequisites for your Kubernetes cluster? So you need a network provider. Definitely you need a kind of network which is an overlay on top of the existing networks. You need a storage provider. You need a way to write your data to some persistent disk or to over the network to an iSCSI or NFS or another shared device. You also need a load balancer provider if you need access from the outside to your services. And next thing is you should recheck your operations use cases. So you will need the capability of adding a node, deleting a node, replace a failing node, and the update of Kubernetes. This is all built in, and with the auto-scaling capabilities of the upcoming versions, you even can do it in a way that it is completely transparent and automated. This is the default in all cloud providers' installations, but if you want to do it on your own, somebody has to catch the signal that the Kubernetes cluster has the wish to have more nodes, more resources, and things like this. So expect some work to do implementing this, but this is not so complicated. You can do it on your own. So basically you have the choice of installing it using a cloud provider or on-premise on your own bare metal. Let's have a look into the architecture of your microservices. So normally people start throwing everything in a container and call this a microservice. This is not a good idea. You should have an idea about your architecture. So first thing is identify all stateless services. These are the services without any internal data. Normally, this is everything which can be restarted seamless. So one way to address this is kettle. So you eat kettle for breakfast, replace it. If it has failed, you don't care about it. You simply throw it away and recreate it. But there is also persistent data, and these paths won't go away. This is the content of your file system. The database is SQL or non-SQL. It's the state in your messaging system and things like this. And if you see this picture, normally you start from a load balancer level, so this is definitely stateless. The web view and the portal should be stateless too. Maybe you have a persistent cache, but this is not really persistent because it can be replaced and rebuilt, so you don't have to care about it. Next thing is your middleware, your business logic, where you have your main app, your notifications, user profiles, etc. And the most important thing you should care about is the stateful layer, the persistent services. So my advice is, if you go to a cloud provider, then simply use the services which are there. There are a lot of examples you can use in the Google Cloud, in the Amazon Cloud, or at any other cloud provider. And if you don't have to care about persistency, a lot of work is unnecessary. So if you make it to deal only with cattle, with stateless services, you are in a perfect shape for using Kubernetes on scale. And the way you do it is that you look into your application, separate all the processes you need for running your application, and put each process into a container, and bundle the containers which need to be on the same host, which need close interaction, shared file system, same IP address, and so on, into a pod. You can use anything what you want inside the container, but there are binding contracts to the outside. For example, you should only have one process. You should write to standard out that the logging can be caught by Kubernetes. You should definitely terminate the container if the main application has died, so that the entire pod can be replaced. Because everything in the pod is a stateless service, replacement of the pod only means we restart the old version or a new version, and everything works as expected. And because we can scale, we have high availability and can run our services without interruption, even if some pods fail or we replace them during a visit of a user. Our companies are already using it. So there are a lot of examples from American companies. We have 2 examples from Germany. One is Immer. It's a Deutsche Telekom subsidiary. They are basing all their internal processes and the entire structure of the application onto Kubernetes, and they use it in the Amazon cloud. There is another big German DAX company, so they have finished their proof of concept and they want to get productive on bare metal cluster in their own data centers in the 3rd quarter of this year. So yes, people are using it and they are quite excited how they can manage their infrastructure with Kubernetes easier than ever before. What are the building blocks of Kubernetes? So I already mentioned the pods, which are containers running together. then next thing you need to know is a replication controller. So the replication controller controls how many instances of a pod are running in parallel. Then you have services. Services are more or less contracts to the outside. So the replication controller and the pods expose pods, and the services gather these pods that they can be used and look like a single service, and you don't have to care from the outside how many instances are run and how many processes are running to provide you with a certain service. The next important thing is persistent. So persistence means that you have access to external resources. External here means, for example, databases, but you can also base your databases on local disks, of course on cloud storage. David already mentioned it. There's one thing, every database has its own philosophy of replication. Therefore, is no general way of saying how you should run a database in the cloud. Obviously, a database should be also high available and as let's say, should be as available that you don't see an interruption of anything because a hardware fails or a node goes down. So this means replication, and replication is complicated. We have some experience with setting up typical cluster setups, PostgreSQL, MongoDB, MySQL. But normally, if your cloud provider offers your database, your dream database, then you should use it. Backup is another issue. You have to care about your own backup this way, but as you can put it on cloud storage, it's easier than before. If you want, then you can base a database on a SSD, on a local disk, and replicate it through your cluster. So then you have a node, have to create a node pool, which is a new feature in Kubernetes. And these node pools allow you that you dedicate servers for special high load scenarios, like high load databases based on storage SSD locally, and you can run it quite easily. But then you should care especially about these nodes with these databases and get real high available 100% performant cluster in Kubernetes of your favorite databases. So, yeah, what is a microservice? The container is nearly free, or the processes in the container are nearly free, but to work properly in Kubernetes and in other container architectures, there is a contract. In production, it's important that you can restart pods anytime. So therefore, if a pod dies, it must be really clear that it can be replaced. So there should not be a hanging process waiting for some output and the main process died in a container. So as a pod consists of multiple containers, and the container should only have one main process, the container terminates and the pod terminates if this process dies. So this is the main thing you have to guarantee, that there are not other processes keeping the container alive if the main process has died. And one last thing, it should write only sort of standard output, that the Kubernetes framework can catch up the logging, and that you can analyze and indicate this from the kube control command. This is the only thing. This is not very much, but you have to care about this. So let's summarize the stateless and stateful services. You should use your provider's database if possible. If self-managed, it's possible. You can be really fast, but it's an overhead. And and you should change your mindset that you move everything into ephemeral deployment units, which can be replaced easily. Even if you run a stateful database on a local disk, you should set up the replication in a way that it can be restarted on any other node in this node pool without interruption. So even if the data is not ephemeral, the process serving the data to the outside world should be designed as a stateless process. This is not difficult, but you have to care about it. So normally we see a lot of virtual machines in our customer's environment, and then the operating system instances are turned into microservices. As I already mentioned, the process is you create them as pods, which are created together, running on the same node. This is a guarantee of Kubernetes. They are terminating together, they share a single network address, and they can share volumes. And then a VM cluster turns into pods running on Kubernetes. Again, think of Kettle, stateless containers, and the pads are your databases, your valuable data, and it should be on a different host and with a different philosophy. This is so important that I repeated it now several times, but this is a key to success of running services in Kubernetes. One more thing is the configuration management. You should try to put most of the configuration into the pod at build time, and you should not configure your pods, which are completely ephemeral, in production or on running systems. This is possible, but I don't consider this as a good example, and it makes the pods quite heavy and large. So yes, it's possible, but it's not necessary, and this is one thing you should care about, that it's separated, that you do it before you roll out the container on a production environment. It might be that you already have invested in big frameworks, virtualization management systems like OpenStack, or you already have a Mesos cluster running. And what shall I do if I want Kubernetes and I have already OpenStack or Mesos or any other framework? Fortunately, OpenStack and Mesos work well together with Kubernetes, so there is no need to make a hard cut, throw it out of the window and use something completely different. No, Kubernetes works well with OpenStack and with Mesos, so you can stay with your old and bulletproof systems and integrate Kubernetes in that. But you don't need it. If you start from scratch, you don't need the overhead of these frameworks. Another thing which is important is monitoring. There is one tool which has been well established. This is Prometheus, has been designed by SoundCloud, and it has been designed with a container mindset. So you can use it, download it, and do all the monitoring of containers with Prometheus. We are using it in a customer project, and it works quite well at the moment. Networking always was complicated, but it's getting better. For Kubernetes, you need network providers. So there is a lot of choice here. We had Flannel, which is integrated by CoreOS, and we had Calico, which has been ported from OpenStack. Fortunately, they announced that they go together and create a new network provider, Kennel, which is able to integrate in both ways. So Flannel does an overlay network, which is nice, but on a big scale might have the impact that it is not really routable, or that it does not work with your network infrastructure. And then Calico came into the game. They can do border gateway protocol and integrate well in the existing network infrastructure. So both companies or both projects now go together, and it's Canal, and you can use it. Then it's optimized both for the container world and well integrated in the network infrastructure. There's of course Open vSwitch. A customer is using it and it works well. And there are some proprietary providers for software-defined networks. If you really have special requirements, special hardware, special security restrictions, then this might be interesting for you. But this is not something you would choose on the first day and use it. So network, if you have a network provider, or if you have already an existing network, I think it can be easily integrated by Flannel and Calico or Open vSwitch. So if you want to run your own Kubernetes cluster in your own data center, then of course you have to care about load balancing. It's for scaling, it's for high availability. And Kubernetes has a concept of a load balancer provider. So if it's well implemented, you simply do something like type load balancer in the service, and automatically it creates a load balancer rule and an address for you. You can write these examples how to do it for F5 load balancers, but expect this kind of thing not a very easy task. So you, the main challenge here is the integration to the load balancer. But if you have experience with this, this could work quite well. And if you don't need such a sophisticated solution, only want to have some rules for services and paths, Ingress is a kind of HTTP reverse proxy, and it integrates well into Kubernetes. And I think 90% of the tasks of the load balancing in the future can be mapped to Ingress. So thank you very much for your attention. If you have more questions, you can ask us. You find special blogs on our website. We offer trainings. And if you need professional services for Kubernetes, we are quite happy to support you. Thank you very much. And yeah, back to Mariana.
Yeah, thank you for your attention. I'm going to look into the chat if I see questions. At the moment, I don't see questions, so please feel free to ask me anything now, if we can help you, if you have open questions. We will put the presentation into Google Docs and announce our services this way, and you can go through it, and we will do the webinar again and put it into YouTube so that you can repeat it. Feel free to send an email to thomas@endocode.com, and we will be happy to help you. So yeah, I don't see questions at the moment. Oh, is this the Q&A button? Oh, no? Then thank you very much. And
yes, hello again from me. Thank you, Thomas. Thank you all for attending and watching the webinar. I just want to draw your attention to the 3-day training that Endocode is running on Kubernetes. If you would like to attend it, or if you just have a question on the presentation that Thomas ran, or if you didn't have a time to post any question in the registration form that we had, please feel free to write to thomas@endocode.com. You can schedule a call with Endocode or a meeting, and just to see if their skill set in containers, virtual machines, and Kubernetes could be helpful for your business to scale. I also wanted to draw your attention that this is the beginning of a series of webinars that we're going to run on several topics, and we really want to hear your opinion. So feel free to write me and Mariana at google.com if you thought of a topic that is of interest of you and you didn't hear it right now, and just to give us your opinion on what would you like to see on the next webinar, as well as we are learning now because this is our first webinar. So please send us any feedback, what you liked and what you didn't like. Thank you so much for watching. Stay tuned on our YouTube channel, which is going to be a Google Cloud Platform NACE, which is Northern, Central, and Eastern Europe, the region that we cover. I'm going to share the channel and the video there with all of you that registered for the webinar. Have a great weekend. Bye from us.
Goodbye.